Hey y'all, my name is Celeste McFarlane. I'm from Charlotte, North Carolina. Some of y'all may recognize me because I'm a cheer coach here at CSS. I'm a rising senior gay at Columbia University studying chemical engineering with a minor in entrepreneurship and innovation. So a little bit about why I chose my major. I've always loved math and science. Particularly chemistry, but more so just math in and of itself. Um, but I wasn't sure what I wanted to do with it, and so engineering seemed like an obvious choice because it's a lot of math and science, but specifically chemical engineering because I think it's one of the engineering disciplines that has the most diverse options. I'll give credit to mechanical engineering too, but for my point, if you looked on the website of Columbia's chemical engineering department and the mechanical engineering departments, you'll see a super diverse range of research topics. And I don't think any other engineering major has that sort of like breadth of just like research going on in it. So I knew that if I chose chemical engineering or mechanical engineering, I could have an opportunity to do whatever I wanted with it once I graduated. So what can you do with chemical engineering? So a lot of chemies are pre-med, pre-dental. There are even pre-law chemies because a lot of chemical engineers go into patent law because you're thinking about new technology and especially like consumer packaged goods, which are like toothpaste, makeup, detergent. A lot go into consumer packaged goods in and of itself, whether it's research and development for these things or manufacturing the scale up of these processes. A lot of people go into pharmaceuticals, whether it's working as a pharmacist or doing like manufacturing for pharmaceuticals or doing research and development for it. Some go into biotechnology in the medical fields, as in like creating different. I'll get into that later, but like creating different physical technologies for the medical fields. Some go into computer science. We actually do a lot of coding in my major, so a lot of people take that route. There's actually a big pool for chemical engineers in finance. I know a good number of people going into finance. I think a lot of investment banking people are always looking for chemical engineers because they're looking for people to understand like new biotechnology to invest in, pharmaceutical industry. There's a lot of people just looking for people with that expertise. And additionally, when thinking about finance, a lot of the math we do is very similar, whether you're studying the flow of fluids, the flow of energy. It's very similar to like understanding the flow of money. So there's a big number of chemical engineers in finance. And then finally, which is where I'm going into, is consulting. Same thing with finance. They're always looking for people who understand the technology world and the the medical professional world, and chemical engineers, because we do a lot of basic science, we do a lot of math, we do a lot of coding, we have that understanding. So a lot of chemical engineers go into consulting as well. Specifically, I'm looking to go into more of the data science realm of consulting, doing a lot more like data analytics for consulting companies regarding like the pharmaceutical industry and like the healthcare industry. That's like what I'm really interested in. Um, so a question I get a lot is, why am I not working in traditional chemical engineering? Um, I think the more I spend time in my major, I realize that my favorite thing is working on projects. I like problem sets are fine, exams are fine, but that I don't really enjoy those. I love projects, specifically the part where you write reports and you get to create a narrative out of data. And so I realized I like talking more about science and math than actually doing it. So I wanted to be in a space, in a job where I got to create narratives about science and math rather than just doing it. And then I also like wanted to be in the city, and chemical engineering, unless you're working as like a chemist doing research, there's not a lot of opportunities in the city just because of space. Like manufacturing plants can't fit in Manhattan. And well, I'll get to this later, but I'm not particularly interested in research. And I don't want to have to move to like Arkansas to do manufacturing work. So a little bit about my background and like the different jobs I've worked in. In high school, I worked in a very traditional chemical engineering lab. I worked on analyzing the decomposition profile of a polymer used to create carbon fiber. And carbon fiber is a really, really strong material, stronger than steel, and it's very like eco-friendly to create. So I worked on looking at the decomposition of that polymer and seeing if there were any safety concerns, because to make carbon fiber you have to burn the polymer at extremely high temperatures. That lab wasn't a wet lab. It was like mostly using really high power analytical chemistry equipment on like solid materials and doing a lot of data analysis, sorting through like the results, and like I had to have an understanding of the various molecules that came out of the analytical chemistry equipment, and using like my knowledge of organic chemistry and polymer chemistry to build like a profile, like what reactions would make sense for this profile. I actually took a year off in between high school and college, and during that time I worked in another lab at the University of North Carolina, Charlotte, and this is actually a mechanical engineering lab, and I worked to extend preservation times for livers for liver transplants. Especially, there's a big issue for transplants of livers because they're only viable for a certain number of hours, and if you're in a more rural area, it's really hard to get a liver in time if one's available, if it has to come from a far area. And also there's just a lot of research that is done on liver cells that can be done, there's a lot of research that's done on liver cells, so if you can preserve them longer, then more research can be done on the liver itself. And so that was using a mechanical system, a liver tissue perfusion system, where they would perfuse a liquid through it, but you had to use knowledge of fluid mechanics to make sure you're not disrupting the liver's tissue as you're perfusing the preservation liquid through it. Summer after my freshman year of college, I worked at the University of Washington, Seattle, and I worked in the pharmaceutics department of pharmaceutics, at UW. There I worked on I worked on a project involving the creation of a targeted long-acting HIV treatment. So while HIV, you can live with HIV and live a healthy life, there's a problem with pill fatigue because HIV is so adaptable. You have to take multiple medications to target the various stages of cell reproduction. So especially in low-income areas and then developing nations, there's an issue with pill fatigue, and having to take multiple pills a day and accessing multiple pills a day is just a big burden. And so the thing about HIV is if you miss one pill one day, your viral load will rebound really quickly. So this product is an injection that combines 3 HIV medications in one format, and it's supposed to be injected biweekly. So that takes off a lot of pill burden. There's currently no other product on the market like this. And so it was really cool to be a part of that development. I worked mostly looking at the safety of that product and doing animal studies and toxicology studies. So I worked in a lot of labs. I've done a lot of research. And like I said before, my favorite part of research has always been looking at the data and creating poster presentations or writing reports or creating PowerPoints, those type of things I really enjoy, but I don't want to be at a lab bench pipetting things all day. So for me, I was yes, I enjoy this research, but I love talking about it. So that's what made me think maybe consulting's for me. The summer after sophomore year, I did research and development for a startup called Kinos that was actually bred out of Colombia. They do disinfection science. They have a product called Highlight, which it's a spray or a wipe. And when you wipe a surface, it's bright blue. And then it fades according to the contact contact time of the disinfectant. So if you're using bleach, it's blue until it's completely, the surface is completely disinfected. So like, for example, most bleach solutions in hospitals have like a 3-minute contact time where you're not supposed to put anything else on the surface for 3 minutes, just to make sure it's completely disinfected. So that way, when you're wiping a surface, you know when it's completely clean. They actually did a lot of work with the highlight spray during the Ebola crisis. They actually played a really big role in helping slow that spread with their technology. So that was really cool. Same thing. I love the people at Kiddos so much, but again, research not for me. But I did realize that like working in a startup, that I love the business side of like product development, thinking about like what is marketable, what is manufacturable, not just thinking about the science in and of itself, but thinking about the big picture. I really enjoyed that. And then this summer, I'm doing 2 things. I'm doing data analysis for a professor in the chemical engineering department who works with atmospheric aerosols. So there's a big data gap about pollution in developing countries where it's arguably more important to know, because when you're thinking about like India and like big cities, you're like, there's a lot of pollution, but we don't have a lot of data on it. So collecting this data is very expensive. They're really high quality sensors that cost sometimes hundreds of thousands of dollars. And then they're really affordable sensors that are like $100 or even sometimes less than that. So the idea is in these different areas to buy like one really big high cost sensor that produces really good quality data, and then create a network of low cost sensors around in the same area around the high cost sensor, and then calibrate the low cost sensors based on the high cost sensor so that you can get high quality data out of the low cost sensor. So that's what I'm working with. I'm doing like machine learning type data science to work on calibrating the low cost sensors. And for the second half of the summer, I'm working at a consulting firm called Analysis Group that does mostly like healthcare consulting and litigation consulting. I will be working mostly with healthcare consulting, hopefully in the pharmaceutical industry, because that's where most of my interests lie. So I'm really excited to do that. They're based in Boston, but I'll be here remotely. Okay, so now that's a lot about me. Some more about Chemi. So what do my classes look like? I do a lot of math. Chemis, we have a lot of math requirements, but I actually enjoy that. I'm weird. Everyone's like, what's wrong with you? I find like ordinary differential equations very calming, and like a mindfulness way, not like, oh, I enjoy it, like, oh, this is fun, but in a way that it's like, like how doing Sudoku or doing a puzzle is very calming. I find that way for calculus. So we do a lot of math, and even in our classes, it's not just like we learn the math, we actually apply math. I think Chemi is very similar to like an applied math major. The thing about Chemi compared to the other engineerings is we do the most basic science. We have the most basic science requirements. So I take a lot of chemistry. You can take a lot of biology if you want, because we have like advanced science requirements where you have to take like different basic science classes. I've taken classes on like aerosols, taken classes on like colloidal chemistry, which is like lotions and creams and all of that, and soaps. I've taken classes on like the pharmaceutical industry. A lot of people take like molecular biology, aside like from the math and the physics that we all take. So we take a lot of basic science classes as well. So if you're really interested in the basic sciences, but you're scared that like engineering will just be all math, I think chemical engineering is a really great choice. Favorite class that I've ever taken, I'm tempted to say ordinary differential equations, but I don't want to be that person, but I guess I am. Like I said, I find it very calming. And just like the applications of ordinary differential equations, like basically any phenomenon can be studied with a differential equation, can be modeled with a differential equation. So there's just so many different applications. Or another class I really enjoyed was called Analysis of Chemical Engineering Problems, which is where we was mostly coding to analyze different chemical engineering processes, whether it was manufacturing or a certain reaction. We just used Python mostly to look at how these processes occur. Hardest class I've ever taken was my heat and mass transfer class. It was very topical though. We studied a lot of really important things like drug release from pills and capsules. Our final exam was entirely on COVID and the coronavirus and the transmission of it. If someone sneezed 2 meters away from you, what's the concentration in the air next to you? So it was very topical. One exam was literally there's a volcano and there's a river of lava and you have to cross the river of lava and you have a physics reference manual. How are you going to do it? Create a plan. That was literally an exam. It was crazy. So it was a very difficult class, but I also feel like the material was really important. The coolest project I've ever worked on, I think sophomore year it was, we were told to create a colony on the moon. We were given one reaction and told to scale up one reaction on how to produce oxygen from lunar rock. And we were told to scale up that process and use that as a basis for creating a colony on the moon and to analyze the economics of the situation and how much it would cost, and just genuinely every single aspect of how would you build a colony on the moon. That project was really cool because the subject was really cool. It was also very challenging because you had to make a lot of assumptions, and that's what engineering basically is. It's making assumptions and justifying them. And some of the assumptions we made were crazy and made no sense, but we had to justify them because there was nothing else to do. A lot of the scale-up processes require a lot of advanced manufacturing equipment. And how much do these things cost? Weirdly, there's a lot sold on eBay, so we could use that, but we called a bunch of companies to get price quotes, but nobody wanted to give price quotes to a sophomore in college, so that was kind of difficult. But yeah, so that project was really cool. Okay, so I think that's all I have to say. But if you have any questions, feel free to reach out to me. I'll put my email on the screen here, but it's cmm2349@columbia.edu. If you have any questions about chemical engineering or just engineering at Columbia or college applications, getting into Columbia, all that jazz, I'm happy to answer those. Thank y'all for listening. Bye.